Okay, welcome to the second part of our Unit 5 review. Just make sure you understand what's going on here. You've been given a packet that goes along with this, several problems that will help you prepare for the test. As we go through this, I want you to locate the examples that we're working out in the video and follow along with them in the packet. Work them out with me as we go through this. Once you get that, you have some examples now to answer the other questions in the packet that will be similar to those. Before you get to the test, you want to go back and review these examples, make sure you're following the steps we're going through and you understand these processes, and be prepared to ask questions in class. We'll have some time in class briefly before the test and also today during class that you can ask questions. If you don't understand something, of course, it's very important that you get it figured out before we take this test. Okay, we're going to jump in and look at our first example here. It's asking us to simplify this rational expression and identify any values for which the expression will be undefined. So first off, we want to make sure everything is factored out in this example. We can't factor our numerator, 9x to the third, but we can factor 3x squared plus 15x. There is a greatest common factor between these two, and hopefully you can identify what that value would be. We're going to take a 3x out of both of those terms. So we have 9x to the third over 3x, and that would leave x plus 5. And of course, we should understand that 3x times x plus 5 would give you 3x squared plus 15x. That's where that comes from. So we have that set up, and now that we can do that, we will now look and see if there's anything that can be simplified here in this rational expression. As I look, I can see that 3 will cancel out off the bottom, and it will change this 9 to a 3. So that will be the first thing that cancels out. Also, this x down here will cancel out as well. It'll cancel out one of the x's up here, so this x to the third will now turn into an x squared. So what we end up with is 3x to the second, and x plus 5 would be left on the bottom. Now again, looking at this x over this x to the third, or excuse me, x to the third over x, one way to think about that is subtracting the exponents. Another way of thinking about it is canceling out powers. So however you choose to think about that is fine. I know a lot of us just say we're going to subtract the exponents there, and that's the same thing we would get either way. The next thing we need to do is identify any values for which the expression is undefined. Undefined, real quickly, means that the denominator, if I can spell denominator is equal to 0. So we need to identify any values of x that would make our denominator here, x plus 5, equal to 0. And hopefully we can see that. Of course, I should have gone back to this value, and I've got two parts here. Of course, x plus 5, we would want to say that x is not equal to negative 5. But you also had this 3x here that was there before we did anything else, before we started eliminating things. And what value of x would make 3x equal to 0? That would be 0 itself. So x cannot equal negative 5, and x cannot equal 0. So this is part of our answer along with this. Make sure we get both parts of that answer, as we were asked to supply both. So to get the correct answer on the test in this format, you would need to give both the 3x squared over x plus 5 and the fact that x is not equal to negative 5 and x is not equal to 0. Okay, moving along to our next example, we're asked to multiply or divide these expressions. We're going to, in this case, assume that all expressions are defined, so we don't have to worry about what values of x would make it undefined in this case. But we are going to follow the process of multiplication. Before we do that, we're going to want a factor. And the reason why is that we can only cancel out factors. If we're going to do any simplification or combining or anything like that, we're going to have factors to work with. We can't just cancel out, say for example in this, we can't just cancel out those x squares as if they were canceling each other out. It just doesn't work that way. We'd have to get those trinomials factored out and see if any of the factors cancel out. So with that said, we're going to go in and start factoring out. We factor out x squared plus 2x minus 3, looking for factors of -3 that will make 2x. And hopefully you're already saying, Coach Hunt, it's going to be x plus 3, x minus 1. I know that, okay? And we are getting pretty comfortable with factoring, so we should know that that's x plus 3, x minus 1. Looking at the bottom one, the denominator, we should be able to pick up on the factors of 12 that will add to make -8. And real quickly, that would be x minus 6, x minus 2. So we have that, and then we look at our second fraction over here, which is x minus 2 and x plus 3. They're already factored out. We can't break those down anymore, so we're just going to go with them. So as we look at this, you can start noticing some of these are going to cancel each other out, some of these factors. To cancel out, you need something on top to match up with something on bottom. And as we see, we have an x plus 3 on top, and that cancels out the x plus 3 on the bottom. Also, x minus 2 over here on that bottom will cancel out this x minus 2 on the top. So as we do that, we have not a lot left. So we'll just carry it over. We'll go from left to right, and we'll multiply everything out. Our final answer here will be x minus 1 over x minus 6. And that's it. So, real quickly, the process of multiplying and dividing basically just means that we need to factor everything out, cancel out the factors that cancel out, and then move everything over that we have as our final answer. All right, we're going to take a look down at this other example here at the bottom. And this is not a multiplication problem like the prior example was. This is a division problem. And when we see division, it basically works the same as multiplication. However, we need to do one thing additionally to that, and that is take this second expression and flip it over. So we're going to basically get the inverse of that to work with. So what we're going to have at this point is x to the 4th y over 3x y to the 4th times, notice that my division changed to multiplication now once we flip it over, 9y squared over x squared. And some of you have used the term keep, change, flip to break down that method. That kind of fits this process, and that's fine to use. We have monomial factors or monomial terms here in these expressions, so they don't really factor out. A method that I suggest at this point is to just take your fractions and multiply across and get everything all together into one big fraction, and then start looking at what cancels out. So as we do this with our numerators, we've got 9x to the 4th, and then y times y squared would be y to the 3rd. And then we come across the bottom, we can work with the denominators. That would be 3. X times x to the 2nd would be x to the 3rd. And then we have y to the 4th. So now we have one big thing to work with. We can take the 9 and 3 and work with them. 9 over 3 would simplify, and that's going to simplify to be a 3 on top. The 3 off the bottom will cancel. X to the 4th over x to the 3rd. You can think of it as subtracting the exponents. 4 minus 3 would be x to the first. And then we can go 3 minus 4 for the y's, and that would be -1. Or we can just think that since the 4 is the bigger one down here, we are going to be left with our answer on the bottom. So what we have, and I'll clean it up a little bit, we have 3x over y as our simplified answer. And that's all it is to division. You basically do the same thing you would have done with multiplication, except you flip over your second fraction first, and then just multiply across. Of course, if we could have factored anything, we would have factored it there and simplified from that as well. So multiplication and division. This one's a little different. We've got a problem where we're going to add or subtract. In this case, this is a subtraction problem, so we'll be subtracting. So what we're going to do first is remember that whenever we are adding or subtracting, we must have common denominators. You've got to have common denominators, meaning the numbers on the bottom have to be the same. And in order to do that, we're going to have to make some adjustments here. So first off, I want to factor anything that I can in denominators. This denominator here will factor to x minus 6 and x plus 2. So we're going to use that x minus 6 and x plus 2 along with this x plus 2 and help us to identify the least common denominator. So the least common denominator in this case, and as we've said earlier, the least common denominator includes all of the factors from the problem, and that would be x minus 6 and x plus 2. So we're going to want to get that on the bottom of both of our fractions in this case. So let's look at what we have. Let's rewrite the problem. We've got 1 over x minus 6, x plus 2, which is just the version of this that we got. We're going to subtract that subtract from that x over x plus 2. Well, we need to get these denominators to be the same, and if you look closely, you can see that this one, the first one, is just got an additional piece that the second one does not have, and that would be an x minus 6. So we're going to multiply an x minus 6 into this denominator as well, so that we have the same thing. To do that, we must multiply it times the top so that we don't have any major changes in the values. So we're going to work with it in this format. That's going to leave us with 1, which comes from the first one. Let's see if I can write this a little straighter. 1, which comes from the first one, x minus 6, x plus 2, minus what we get when we have x squared minus 6x. And we'll talk about what's going to happen with this in a moment. Because of that minus sign, we have to make one more adjustment. So what we're going to have now is 1 minus x squared, and because that's a minus here, that's going to change this sign when we put it through to everything. That's going to make that a plus 6x over x plus 2, x minus 6. So now we're ready to clean that up just a little bit, and when I say clean it up, I'm basically saying we just need to rearrange it. We would say negative x squared should be written first, plus 6x, and plus 1. That part does not factor, so there's nothing else to break down. And we're left with this as our final answer. So again, just recapping, anytime we add or subtract, we must identify what that least common denominator was. In this case, it was x minus 6 times x plus 2. So we wanted to get x minus 6 times x plus 2 on the bottom of both of our fractions. So to do that, we had to multiply in an x minus 6 here in this second problem, in this second fraction. And the way we did that, we did it on the top and the bottom. We distributed it out and then combined our numerators to get our final answer. All right, our last example is an equation to solve. We've been looking at these most recently. In this equation, we've got three different denominators, and to get denominators out of the equation so that we don't have fractions or anything like that, we just have an equation to work with, you're going to have to multiply everything in the equation by the common denominator, and that will cancel things out. So let's look at what that does up here. Our least common denominator is going to be found by factoring out. Our factor for this right here would be 3 times x minus 2. We have a greatest common factor, we have a greatest common factor of 3. So it's 3 times x minus 2. X minus 2, of course, is factored. 3 can't be broken down anymore either, so we have 3 times x minus 2, 3, and x minus 2. So our least common denominator, going to include everything there, that would be 3 times x minus 2. So we're going to use this and multiply it through to every part of the problem and see what happens. So let's start off by looking at the problem. We've got x over x minus 2. We've got x over 3. I'm leaving a little extra space there, you can see. And I've got 4x over 3 times x minus 2. So we're going to take our 3x minus, or our 3 times x minus 2, and we're going to multiply it in everywhere we go. So we've got x times 3 times x minus 2. We've got x times 3 times x minus 2. We've got 4x times 3 times x minus 2. And let's look and see exactly what's going to take place now. We don't want to multiply everything out yet. We just want to have it there and look to see what we can simplify out first. So we've got x minus 2 and x minus 2 cancel out in our first term. In our second term, the 3's cancel out. In our fourth term, 3 and x minus 2 will cancel out, and that leaves behind a problem that's going to be much easier to work with than what we had to begin with. So over here we've got x times 3, of course that's 3x. In this problem we've got x times x minus 2, which would be, when we distribute, we've got x squared from right here, and then minus 2x. And then in our last part, we've got nothing left but 4x. So this complicated problem that we started off with is now looking a lot simpler. It's still quadratic though, and we're going to have to work with that. Let's clean it up a little bit. You've got 3x and minus 2x. Of course, that makes x squared plus x, and that is going to be equal to 4x. So our next step would be to get everything over on one side, and we've got the x squared on the side we like, so we'll subtract the 4x over there, and that's going to leave us with x squared. See if I can make a minus sign. Minus 3x is equal to 0. So at this point, we have a couple options to solve quadratic equations, but probably the easiest in this case would be to just factor it out. We have an x on both of these terms, so we will factor that x out, and that will leave us with x times x minus 3. So then we'll identify the factors as x and x minus 3, and we want to see what values of x would make either of these factors equal to 0. So what value of x would make this factor equal to 0? Of course, it would be 0. What value of x would make this factor equal to 0? That would be 3. So we've got x is equal to 0 or 3. And of course, the last step, and you don't want to forget to do this, the last step is to check our answers. We want to make sure that we don't get any undefined terms, meaning we don't get any denominators to equal 0. So I've got x is 0. Let's test that one out. If we look at x equals 0 in the denominators up here, it does not make any of these denominators 0. So that would be okay. And then we test the 3. We're testing out positive 3. So we plug 3 in here, that'd be 3 minus 2 is 1. Of course, that's not going to change that. And then we plug 3 in here, that would give us a value of 3 as well. So we don't have any issues with either of those answers, so they're both good. And we can now say that our answers are 0 or 3. Okay, so we've looked at quite a few examples that will help you prepare for the test. I want you to practice by going through the rest of that packet and making sure you know how to do the remaining problems. If you can do those problems, you should have no issues on the test, because the test will be very similar to these. So take some time, practice them all, spend some time with them, working them out, and good luck on the test tomorrow.